Lesson 2, Hydraulic Brake Systems, Critical Task 091, 62B with 1005, 6091, 62B 3054. Introduction. Hydraulic steady the liquid with the motion with the pressure exerted with the liquids are conveyed with the pipe with the conduit with the hydraulic brake system, pressure live with the brake pedal with the transmit the brake mechanism with the liquid to be understand without the pressure transmitted hydraulic brakes for the necessary to understand the principle of hydraulics. Two well-known hydraulic principles are liquid with compression and liquid distribution. Part A principles 2-1 compression. Liquids can be compressed in the ordinary pressure that may be demonstrated placing the weight on top of the piston with the forward fitted in the jar of the 2-1 force of the weight force of the weight that does not change the level of the liquid, thereby does not diminish the volume of the compressed liquid. Figure 2-1 shows the non-compressible liquid level to remain the same as the weight in the piston. Distribution of the force exerted by any of the point of the confined liquid distributed equally throughout the liquid in all directions. This is force of 20 pounds, including the piston of the weight of the place of the pound, including upon the liquid in the jar. The piston of the jar is the area of the 5 square inches. Hydraulic pressure increases with 20 to 5 of the 4 pounds per square inch shown in figure 2-2 with a gauge inserted at any point of the jar will indicate the pressure 4 psi, since the liquid transmits the pressure equally throughout the jar. 2-3 illustration. The use of the hydraulic principle is illustrated with the interconnection of two jars with the same diameter with the contained liquid. If the force exerted with the piston with the one jar of the figure 2-3 piston of the other jar will receive the same amount of the force due to the transmission pressure for the liquid of the air of the two pistons are equal. The move of the one piston produces initial boom with the other piston becomes liquid is not compressible, therefore maintains the same volume of the following paragraphs contain the illustration of hydraulic principles. Two jar illustration become by connecting two jars together, the second jar having twice the diameter, the first through the 4 times the area. The result is somewhat different, although the same effect applies. Figure 2-4 with the force exerted with the piston, similar other jar with the piston, larger jar with the 4 times the much of the force of the hydraulic pressure that acts upon the 4 times the area. Since the liquid always occupied with the same volume of the large piston with the move of the 1/4 as far as the small piston. 4 jar illustration. The 4 jar small diameter connected with the center jar with the approximation. Figure 2-5 the 4 wheels brakes and obtained with the force exerted with the piston, center jar with the transmission, each for the other jars of the piston. Each jar will receive the identical force but will move only 1/4 as far as the central piston. The 4 jars that have a larger diameter, the central jar, the total pressure on each of the 4 pistons is greater than applied to the central one. Each of the 4 pistons moves less than 1/4 as far as the central piston hydraulic brake system operates in such a manner. Figure 2-2 shows equal distribution of force of the confined liquid. The piston having the area with the 5 square inches of 20 pounds of weight in the 4 different confined liquids. Force exerted, the distance moved, they equal with the force obtained. Figure 2-3 distribution of forces in the hydraulic using the same size pistons. Figure 2-4 with the distribution of force of the hydraulic system using the different size pistons. The small piston, the distance are proportional to the diameter of the larger pistons. 4 jars connected with the center of the jar with the force of the distance reached and moved and distance moved. 2-4 operation of the hydraulic brake. The force of applied to the piston with the mass of the brake pedal operates the piston linkage. Each the wheel brake cylinder with inside the cylinder pole with the piston. They are connected with the brake shoes where the brake is deprived of the moving the piston with the master cylinder forcing the brake fluid from the master cylinder through the tube of the flexible holding 4-wheel cylinders. Figure 2-6 shows the hydraulic system, brake fluids, reservoir pump, wheel cylinders, master cylinder, power cylinder. Fluid type. All hydraulic brake cylinders use the silicone brake fluid. The silicone brake fluid does not free with the boil with the temperature can count with the year round. Operates with the construction equipment of the fluid of the brake fluid enter the wheel cylinder between the opposed pistons, making the pistons over the brake shoes outward with going with the brake drum. The pressure of the pedal will increase. The more hydraulic pressure of the built up the wheels, of the more is forcingly exerted against the end of the brake shoe. Brake release when the pressure pedal is released with the retraction. The spring of the brake shoe with the pull of the shoes away from the drum. The force of the wheel cylinder piston with the release of the position force of the brake fluid back through the flexible hose and tubing of the master cylinder. 2-5 brake cylinder power conversion. The master cylinder figure 2-7 is the primary unit of the brake cylinder that converts the force of the driver's foot and the fluid pressure opposite with the brake cylinder and the master cylinder housing aluminum and iron casting more integral of the reservoir with the usable detachable nylon steel reserve. The reservoir carries sufficient reserve fluid to allow the expansion with the contraction of the brake fluid, allowing the brake liner wearing the reservoir filled with the top of the wheel with the seal with the removable filler cap containing the master cylinder easily mounted on the firewall, which allows the easily inspection surfaces less prone dirt and water. Figure 2-7, the master cylinder, starting from the clockwise, the filler cap bypass the primary cup seal of the VLC with the check valve, the return spring of the piston with the rubber port with the retain spring with the secondary cup seal intake port. Construct with the master cylinder piston with the long spool-like member with the rubber secondary cup with the seal with the outer end of the rubber primary cup with the active against the brake liquid just ahead of the inner end of the brake cup with the cape against the end of the piston of the return spring with the inner piston the head with the several smaller bleed parts of the pass through the head of the base of the rubber primary cup with the steel with the top disc held in the outer end of the cylinder by a retaining ring or snap ring acts of the piston top of the rubber boot. The cover of the piston end of the master cylinder of the boot is prevented to prevent any air from being compressed within it. Operation inside the end of the cylinder there by combination of the in and outlet check valve with the held in place with the piston return spring with the check valve with a little different. Most check with the valve with the less fluid pass through the one direction only. If the pressure is applied to the valve, the fluid can go in the random in either direction. That means this keeps some of the pressure of the brake line. Check valve consists of the rubber valve cup of the steel valve escapes. The some lead rest on the rubber valve seats the fits for the end of the cylinder. Some of the design of the check valve consists of the spring operated outlet valve shield on the valve cage rather than the rubber cup outlet valve with the pressure of the operation of the same. The piston return spring normally holds the valve cage against the rubber seal with the fluid vic in the brake line. 2.6 wheel cylinder. The wheel cylinder figure 2.8 change with the hydraulic pressure and the mechanical forces pushes the brake shoe against the operation against the drum. Operation of the wheel cylinder have the mount of the braking backing plate with the inside of the cylinder and the two piston with the move in the opposite direction. The hydraulic pressure at the same time push with the shoes against the drum. Figure 2.8 show the bleed hold of the piston cup of the piston, the return spring and the cylinder housing in the rubber boot. Description of the piston or piston stems are connected directly with the shoe of the rubber piston cup of the face with the cylinder bore against each of the piston to prevent escape of the brake fluid. Light springs between the cup to keep the position against the piston to keep out the form matter of the opening of the cylinder fitted with the rubber boot, the brake cylinder, and the cylinder brake line connection between the piston and the top of the cylinder between the piston with the leader hole of the screw through the which air is to leave the system and is being filled with the brake fluid. Cause and effect through the self of the energizing the action of the sum of the wheel step in the wheel cylinder figure 2.9 with the shoe with the compensate with the faster rear of the wear with the from the shoe with the rear with the shoe with the use of the large piston with the rear shoe receive the pressure offset with the self energizing the front shoe with the desire both of the shoe and independently self energizing necessary to have two wheel cylinders one with the rear. Each cylinder has a single piston with the mount of the opposite end of the brake backing plate from the other cylinder. Figure 2.9 shows the step wheel cylinder, larger piston, smaller piston. 2.7 the brake operation. Previous the brake paragraph that discussed the parts of the brake of the hydraulic brake system. Illustrate happens with the parts of the brake supplied with the release. Assume with the brake cylinder and stub of the vehicle, the hydraulic system filled with the fluid. Operator pushes down with the brake pedal with the link move to the piston with the master cylinder. The piston move the inward primer. The cup sleeve the bypass port, sometimes known as the compensating port. Bypass ports are closed with the bypass port. Closed with the piston T-wrap with the fluid with the head of the pressure with the cylinder. The pressure force with the check valve to open the fluid pass with the brake line. And the piston continue with the move of the force fluid through the line with the wheel cylinder. The hydraulic pressure cover with the wheel cylinder and piston and move the outward force of the brake shoe again for the brake drum. As long as the pressure is kept on the brake pedal with the brake shoe will remain pressed against the brake drum. Brake pedal relief of the brake pedal with the relief of the pressure of the linkage of the pressure drive with the remove of the mister cylinder. The return spring pushes the piston back to the release position. Reduce the pressure of the front piston. The check of the valve. The slow of the sudden return of the fluid of the wheel cylinder. As the piston moves forward to the return of the piston cylinder, the fluid from the passenger cylinder supply tank flows through the port through the bleeder hole with the heat of the head of the piston. The fluid will bend with the primary couple of lips away from the cylinder while the fluid will flow into the cylinder head of the piston with the pressure drop of the master cylinder of the brake shoe. Return with the spring will pull the shoes away from the drum of the shoe. Will pull away from the drum of the shoe. Screw the wheel cylinder piston together and thus forcing the brake fluid back into the master cylinder with the return fluid force of the check valve to close the entire check valve with the force off the seat with the fluid flow to the master cylinder around the outer edge of the valve. When the piston of the master cylinder has returned the release position against the top blade with the primary cup of the overcover the bypass port when the excessive fluids through the bypass port with the reservoir prevents the backs with the locking up with the heat of the brakes cover with the brake fluid to expand. C. The cycle repeated the check valve C with the pressure which piston returns brings the more pressure with the return fluid. The valve will keep slight pressure on the brake with the line with the wheel cylinder. The brake system is now positioned in the max brake application. Part B. The troubleshooting and introduction. This part provides the required diagnosis correcting unsatisfactory operation failure with the hydraulic brake system of the item engineer with the construction equipment job situation created with the required with the Department Army Form 598AE. Figure 210, a troubleshooting guide and a maintenance for the allocation chart and C tractor will be used for the job for the job situation. Requirement: the requirements E for the situation diagnosis of the problem approach rate with corrective action complete with the DA Form 598A. E for the all situation review will be a sergeant heavy construction repairman assigned with the B company 80th Engineering Battalion Combat Heavy Force Chaos Kansas. The U.S. Senior Construction Equipment Repair the maintenance section of the U will have the operator available for assistance. Safety primary consideration. Ensure the engineer shut off all the control transmission lever that are in neutral position. The parking breakers are set and wheels are chocked. 210 initial situation. You receive the DA Form 598AE with the instructions for the troubleshoot with hydraulic brake system and also obtain with the toolbox copy of the TM 524202242001. Proceed with the operator to stand by with the C with the most logical play for the being troubleshooting process. The talk of the C. The operator relay for the was a process for the moving the seat with the assigned parking position equipment wash rack. The reach once when he reached the wash rack, attempt to stop the seat with the servo of the brake, rapidly pushing on the brake pedal without result with having the brake parking to emergency stop and ensure they observe all the safety restrictions that you necessary to personally check with the seat operation. They see there is no traffic in the general area with the operator. The seat of both forward and reverse gears are to verify the wheels of the brakes will not stop. See with the use of the parking brake. See with the hard stand, but there is no other indication where the brakes are failed. You should perform a visual inspection using the following paragraphs to determine the actions which should be taken. This shows the Form DA Form 9988 and equipment maintenance inspection work sheet. Interpretation data with the refer to P Appendix D with the page D3 with the page 83 and 84. Follow the steps 1 through 5 below from the tab. For the step 1, interpret the flag voltage status indicated with the DA Form 5988E. 4 symbols may be appear with a column. Each with the one indicate it's a different fault status. The use of the table 2-1 to define the symbols. 2-1 fault status. A backslash symbol indicates the deficiency of the vehicle operative. The X with in a circle symbol indicates the vehicle may be not be used with limited operation. X symbol indicates the vehicle is an operative status, and a dash means the symbol indicates that the inspection replacement overdue maintenance work order has been replied. Based on the faulty status, the symbol shown with the figure 210 with the page 210 with the table 2-1 with the X indicate with the brakes and the operative status. Step 2 with the troubleshooting guide. Inspect the unsuitable police. If the equipment is disabled, the guide will help to narrow down the possible cause of the discrepancy in the truck on any of the checks that must be made to determine whether or not to correct the problem. The refer to Appendix D with the page G3, paragraph 83, 84 for the following inspection. Determine the paragraph 83 and 84 to describe the fault status stated with the DA Form 5988E. The solution to determine the correct answer. Paragraph 83, Step 1, correct answer. Step 3, continue the visual inspection. See with the make the following notes of the paragraph present for the most possible cover the wheel brake failure in situation. The brake fluid level of the reserve full is full. There are no leakage line. There are no damage fitting. There are no air when bleeding the brake system. Step 4, for Appendix D with the page D3 with the paragraph 83 and 84. Determine the most possible cost solution of the brake of the failure, comparing the notes of the steps in paragraph 83. Problem: when you are the correct solution of the brake failure problem, add silicone brake fluid and B, tighten the replace with the brake line with the fitting. C, with the brake B, the brake system. D, place the brake cylinder in solution based on the fitting of the D for the corrective answer. Report with these findings with the maintenance supervisor you're intended to describe. Determine the level of maintenance needed with the replacement and repair with the master cylinder. Step 5, refer to Appendix D with the D14 with the D15. Determine the property level maintenance locating appropriate level of the column 4 with the problem maintenance level authorized with the replacement of the master cylinder. A, crew. C for crew. B for O, organization. C for F, directed support. D for H, general support. E for the deployed solution. The correct answer is B with the base on the answer of the maintenance supervisor assigned with the task replacing the master cylinder. Remove all the reinstall the master cylinder preparation for the task outside of the engine hood. If it was remove the wheels with torque, the parking brake was set. The suitable containers available to cast the brake fluid with the use of the following step: remove and reinstall the master cylinder. Refer to figure 211. The step 1, tag the line for the disconnect with the A with the reconnecting them. Step 2, the disconnect with the brake fluid reservoir hose 1, clutch with the hydraulic reserve hose 2, the drain each of the hose suitable container. Step 3, remove the wrench, disconnect with the 2 brake line fitting of the 3 and 4 with the 4. Step 4, remove the 3 screw with the 3 spring tension the washer of the brake master cylinder. 7, the discharge the 3 spring tension washer. Step 5, remove the 2 bleeder valves 8 and 9. Step 6, reinstall the 2 bleeder valves 8 and 9. Reinstall the brake. Step 7, reinstall the brake cylinder and install the 2 bleeder valves 8 and 9. Step 8, install the brake cylinder. 7 with the 3 screws. 5 with the 3 new spring washers. 6, and then step 9, when the wrench connect the 2 brake letting and fitting 3 and 4. Step 10, connect the 2 hoses 1 and 2. Step 11, fill the clutch hydraulic reservoir according to lubrication order 52420224-12. Step 12, fill the brake fluid reservoir according to lubrication order 52420224-112. 1-2. Figure 211 shows the removal and installing of the master cylinder. Bleeding of the brake system following the installation master cylinder with the task of the bleed the brake system, bleeding of the brake system, pumping the brake pedal with not sufficient compressed air regulated at 14.5 to 29 psi. Must be used to bleed the brake system for the preventive damage of the do not reuse the brake fluid and conserve the contaminated damage of the equipment. Following step 1 through 13 below figure 212 and page 214 of the brake bleed system. Step 1, remove the 2 brake fluid cylinder reserve cap, the 1 and 2, remove from the 2 brake fluid reservoir 3 and 4 with install the 2 elbows 6 on the hose 5. Step 3, install the rotor adapter assembly 9 to the 2 brake fluid reservoir 6 on 8. Step 4, connect the adapter assembly 9 to the assembly hose 10. Reassemble. Remember to use the suitable container to cast for the brake fluid. Figure 212 to the brake system bleeding. Open only one bleeder valve at a time. Observe the fluid level. The brake fluid reservoir. Do not allow the brake fluid to go in below the minimum indicated before adding more fluid to the reservoir. Step 5. Bleed the brake system following the order. Master 11 in two places. Right rear caliper 12. Left rear caliper 13. Right front caliper 14. Left front caliper 15. Anti-block brake modulator 16. Right front caliper 17. Left front caliper 18. Clutch slave cylinder 19. No, the brake system is given properly with the blade with the steam. Steady stream of the brake with the fluid. No air bubbles come out with the bleeder valve. Step 6. Disconnect the air supply with the 10 with the adapter assembly 9. Step 7. Remove the adapter assembly 9 with the 2 brake fluid reservoir 7 and 8. Step 8. Remove the 2 elbows from the hose. Step 9. Fill the 2 brake fluid reservoirs 7 and 8 with the max indicator with the brake fluid. Step 10. Install the 2 brake fluid reservoirs 1 and 2 with the 2 brake fluid reservoir 3 and 4. Step 11. Fill the clutch hydraulic reservoir according to lubrication order 52420222412. Step lubricating fluid reservoir according to lubrication order 52420222412. Install the outside engine gauge. Step 13. Adjust the brake pedal with the brake pedal readjustment in the stage of the task. Refer to figure 214 with the use of the following step. Adjust the brake. Step 1. Right with the brake pedal with it neutral with the piston rod clearance that must be between 4/10 of an inch. 4/100ths of an inch or 1 millimeter. Step 2. And measure with it not with a tolerance. Adjusting the clearance with the turning the eccentric screw 2. 213. Brake pedal and pedal adjustment. Lesson 3. Compressed air brake systems.